Hey guys, welcome back to some more A-level maths revision. In this video today we're going to take a look at recurrence relations. So it's part of the chapter on sequences in the series. It's a really short kind of topic, so this will be a nice quick video. And I don't think it's a particularly difficult topic, so hopefully we'll find this nice and easy. So let's take a look at the first question here. Again, taken from old exam papers here. So this is question 8 from one of the old C1 papers. So we've got the sequence here, A1, A2, A3. We know A1 is equal to K, and then we know the next term in the sequence is given by this relation here. So A n plus 1 is equal to 3 lots of AN plus 5. Now, we want to find A2. That's what we want to find for part A. So in part A, we just want A2. Well, A2, we'd get that when n is 1. 1 plus 1 gives us A2. So we're using n equals 1. So A2 would be 3 lots of A1 here, plus 5. But remember, we know what A1 is. A1 is K, right? So in that case, all I do is substitute in 3 lots of A1, where A1 is K, so that's 3K plus 5 there. And that's our first part done, just for 1 mark. Part B then, we want to show that A3 is equal to 9K plus 20. So same method again here. This time though, we're using the fact that A2 now is 3K plus 5. So in that case, A3 will be equal to 3 lots of the previous term. That's what this sequence tells us. So 3 lots of A2 plus 5. Okay, well, if we do that, using A2 equals 3K plus 5, that's 3 lots of 3K plus 5, and then we add another 5 at the very end. And at this stage now, we just need to simplify it and obtain the expression that we're given. 3 times 3k, that's 9k. 3 times 5 is 15. So 9k plus 15, and then we've also got the extra plus 5 here at the very end. And if we simplify this expression, we get 9k plus 20, which is what we wanted to find there for A3, so as required for part B there. Okay. For part C then, we're looking at this sigma notation, so now that's just a summation. So we want to find the sum of AR from R equals 1 to 4 in terms of K. Well, don't forget we've just worked out the first 3 terms. We know A1 is K. We know A2, that's 3K plus 5. And then A3, we're given that, that's 9K plus 20. So all that leaves is for us to find A4 and then just sum the terms up. So if we can find A4 now, because that's the only one we don't have, and then we just add everything up, we find the sum in terms of K. So A4 is going to be equal to 3 lots of A3, so it's 3 lots of the previous term plus 5. So that's going to be 3 lots of this, so 3 lots of 9K plus 20. And then add another 5 on, and this will be our A4 here. So if we simplify this, that's 27k there, plus 60, and then add an extra 5, so we get plus 65. Okay, so that's A4 there. So in that case, we know A4 then is 27k plus 65. So all I need to do now is add A1, A2, A3, and A4 together, collect all the like terms, and then we've got our answer. In that case, the sum of AR from R equals 1 to 4, that's just simply going to be K plus 3K plus 5 plus 9K plus 20, and then add on our very final term, 27K plus 65. And if we collect like terms here, what we obtain is 40k plus 90. Okay, so that's our summation there, 40k plus 90. And then the second part, just a little brief one here, we'll do it at the top. We were asked to show that the sum, so that sum we've just worked out here, is divisible by 10. So there's 2 ways of doing this. You can just divide both terms here by 10, so that'll give you 4k plus 9. That'd be one way of doing it. Or you can factor out the 10. So what I'd obtain would be 10 lots of 4k plus 9. Remember, if you can write this as a multiple of 10, then it also means it's divisible by 10. So in that case, 10 divides the summation. Okay. If you've never seen this notation before, this straight bar here, straight line, just means that 10 divides the summation there, like we're being asked. Just a little bit of notation. But again, you can also divide 40k plus 9 by 10 to give you 4k plus 9. Therefore, divisible by 10. That's the other way of doing it. Okay. So just so you've seen the other way of doing it there. But nice easy question to get us started. So let's take a look at the next question. Like you'll see with these questions, they're all pretty similar. So let's take a look at this one. Question 5 here. Again, starting off, we're just finding the next term, so A2. And again, we're given the pattern here, so the next term in our sequence, so this will be A2 in this case, we've got 2 lots of the previous term, so that's 2 lots of A1, and then we subtract C off. But we know A1 is 3, so at this point here, we just do 2 times 3 minus C. So in that case, I get 6 minus C for A2. So that's the first part there, quite a nice one to start with. A3 then, so this is part B. We're asked to show that A3 is 12 minus 3C. So we're just using this pattern again. A3 will be 2 lots of the previous term minus C. Substituting in here, where we know A2 is 6 minus C. So that's 2 lots of 6 minus C. And we also subtract another C off here. So that's 12 minus 2C. And then we subtract another C off here. And if we simplify this, 12 minus 2C minus another C gives us 12 minus 3C as required there. Okay, so that's part B done. Part C then, we're given that the sum of AI from I equals 1 to 4, so just kind of like the last one here, is greater than or equal to 23. So we're asked to find the range of values of C. So if we do that one up here, so again, we've got A1, we've got A2, we've got A3. So the first thing we need to do is work out what A4 is, work out the sum then, and then consider this idea that it's at least 23. Okay, so let's work out A4 first. So that's 2 lots of the previous term. So that's 2 lots of A3 minus C. So what will that give us? Well, that's going to give us 2 lots of 12 minus 3C. And then we subtract a C off at the end here. Simplifying this would be 24 minus 6C minus C. That's 24 minus 7C. So then in that case, we can work out the sum now. So we've got the first 4 terms. So the sum of AI from I equals 1 to 4, well, that's going to be equal to 3, because that's A1, plus A2, 6 minus C, plus A3, which is 12 minus 3C. And then we also need to add on A4, 24 minus 7C. Collecting like terms here, what we obtain is 45 minus 11C. Okay, so that's the sum from 1 to 4 for AI. Now what we know is that this sum here is greater than or equal to 23. So what we know then is 45C minus, sorry, wrong way around. 45 minus 11C, helps you get it the right way around, is greater than or equal to 23. So in that case, we're just solving this linear inequality here now. Okay, I want to make this 11C positive, and I'm going to subtract 23 off both sides. So what I get then here is 45 minus 23 is greater than or equal to 11C. Okay, well, this will be 22, so we know 22 is greater than or equal to 11C. In other words, that means 11C is smaller or equal to 22. Less than or equal to 22 there. Okay, and then at the last stage here, we just divide both sides by 11. So C is less than or equal So 2 there. Okay, so that's our range of values of C there that satisfy the inequality. So 4 marks that last part. Hopefully it made sense. So let's take a look at the next one. Now this next question's quite a tricky one in a way. It actually combines another sequence into it, so we will see that in a moment. So let's take a look at the first part first. Question 10. Part A then. So in this sequence here, U1 is 4, and then the next term is given by 2 lots of the previous term divided by 3. So the first part wants us to find the values of U2, U3 and U4. So U2, well, that's going to be 2 lots of U1 divided by 3. And U1 is 4, so that's going to be 2 times 4, which is 8 divided by 3. Okay? In that case, U3 then will be 2 lots of this previous term, so 2 lots of U2 divided by 3. So that's 2 lots of 8 over 3 divided by 3. If you simplify this, this will give you 16 over 9. Because that'd be 16 over 3 in the denominator. And if you divide it by 3, you'll get 16 over 9. And then finally, U4 then. Same idea. 2 lots of the previous term, so U3 divided by 3. So that's 2 lots of 16 over 9 divided by 3. If we simplify here, so that'll be 32 over 9, and then we divide that by 3, we get 32 over 27. Okay, so the exact values there for U2, U3 and U4. Now part B, so we're carrying with part B up here, we want to find the value of U20. So U20. Well, Edexcel or AQA or whoever your exam board is, they wouldn't expect you to sit there and do this all the way up to U20. So we've kind of got to spot how can we work this out with a quick method. Well, the way we actually do that is by using a geometric series, a geometric progression, right? Because if you notice, at each stage, our common ratio is 2 over 3. If you've got A over 3 and you times it by 2 over 3, you get 16 over 9. And then you take 16 over 9 and you times that by 2 over 3, you get 32 over 27. So it's a bit of a sneaky question. You know, the idea of spotting that this is a geometric progression. You can also notice it by the fact that un plus 1, so if we just do it over here, un plus 1 is given by 2 lots of un divided by 3. We could write that as 2/3 of un, okay? So that's our common ratio there. So R is 2 over 3. So the only thing left here is what is our first term. Well, we're given that U1 is equal to 4. Okay, so in that case, we just need to work out now the 20th term in this sequence. Well, the nth term would be given by AR to 19 for this one. AR to 19. So we know A is 4. R is 2 over 3. And then the power here is 19. Because it's n minus 1. If it's the 20th term, we do n minus 1 there. So this is 4 times 2 over 3 to the power of 19. So just plug this into your calculator. We've got to give that our answer to 3 significant figures. If you enter this correctly, you should get 0.00180 there. Okay, so that's part B done. Part C then, again, we're going to make use of our geometric progression here. We want to find 12 minus the sum of ui from 1 to 16. So I equals 1 to 16. Well, in that case, all we actually need to do here is use our summation formula for a geometric progression with 16 terms, and then just do 12 minus that. Well, that's going to be 12 minus, so the formula is going to be A, which is 4, 1 minus R, so 2 over 3, to the power of our summation, our top power here, which is 16, or the upper limit of the summation, I should say, and then we divide it by 1 minus R. 1 minus R, like so. Okay, so just ignore this part over here. That's for part A. Well, if you simplify this, well, I'll put it into your calculator. Put it into your calculator again because it wants it to three significant figures. So you plug that into your calculator to three significant figures, we get 0.0183 there. Okay, so quite a nice question for part C, so that's our answer there. And then finally for part D, we're asked to explain why the sum of ui from 1 to n has to be strictly less than 12 for all positive integer values of n. So 1 mark for this, we shouldn't expect too much work. And the main idea here is considering the infinite sum, so the sum to infinity here. Well, remember, the sum to infinity is given by a divided by 1 minus r. We know a is 4, and we know r is 2 over 3. Well, let's just plug them in and see what we obtain. So that's 4 divided by 1 minus 2 over 3. So that's 4 divided by 1 over 3. So my notation's getting a bit messy. I'm running out of room, but 4 divided by a third is just the same as 4 times 3, which is equal to 12 there. Okay, so that's the idea here. That's why the sum from 1 to n, whatever n is, has to be strictly less than 12 in this case. Okay, because our sum to infinity is equal to 12. Okay, so that covers part D there. And then we move on to the very last question, quite a nice one to end with, just again showing a different example here. So we've got a sequence, we're given our recurrence relation, so part A, we just asked to write down an expression for A2 and A3 in terms of K. Well, A2 is given by K times the previous term, so that'd be A1 plus 1, like so, and then we divide it by the previous term, A1. We know A1 is 1, so our expression then is K times 1 plus 1 divided by 1. Well, 1 plus 1 is 2, so that's 2k divided by 1, so we get 2k there for A2. Okay, and then once we've got A2, we can work out A3 using our recurrence relation. So A3 is equal to k times the previous term A2 plus 1 divided by A2 again. And plugging A2 in then, which is 2k, we get k lots of 2k plus 1 divided by 2k. At this stage here then, simplifying this will give me 2k squared plus k, 2k squared plus k divided by 2k. Well, I can simplify this. You can write it over, you can split it up into two fractions if you find that easier to visualize. So you can write that as 2k squared over 2k plus k over 2k. And then simplifying each one separately, we get A3 as k plus a half then. Okay, so that's our A3 term there. Now for part B, we want to find an exact value for k. And the way we do that is by using the information they give us. And that information is the fact that the summation of AR from R equals 1 to 3, so the first 3 terms of our sequence is equal to 10. Now we know the first 3 terms, we've worked them out. We know A1 is 1, we know A2 is 2k, and we know A3 is k plus a half. So all we need to do then is add everything up, set it equal to 10, and then solve for k. So the sum then from 1 to 3, well, that's going to be equal to 1 plus 2k plus A3, which is k plus a half. So that's 3k, and then 1 plus a half would be 3 over 2, so we get 3k plus 3 over 2. But we do know that this summation here is equal to 10, so in that case, 3k plus 3 over 2 is equal to 10. So all we need to do now is solve this for k. Well, if I subtract 3 over 2 from both sides here, I can't even speak anymore, 3k is equal to 10 minus 3 over 2. You can get that over a common denominator, so that would be 20 over 2 minus 3 over 2. So in that case, 3k is equal to 17 over 2. And then finally, divide both sides by 3 to just obtain k. So that's 17 over 2 divided by 3, which would give us 17 divided by 6 there. And there we have it, so that's that question done. So overall, that's the topic done, and brings us to the end of this video. I hope it's helped. If there is any issues, again, like always, just be sure to leave a comment down below. Cheers.